Okay, so basically these are the formulas we're gonna be using. Well, let's do the problems. I'm gonna send the formulas in the general group chat. Like, it's not about other group chats, it's about the
This
general
group chat.
specifically.
Yeah, I was about to
And
say
I'm
this
gonna
group chat specifically, but yeah, that works.
and I'm gonna also send this stream specifically.
Yep.
Okay, so let's see. A solution contains 4.80 times 10 to the 9 picograms of magnesium hydroxide in 3.50 times 10 to the minus 5 megaliters of solution. Write and balance the chemical equation. Okay. Okay, so let's do that. Part A. Okay, so we have magnesium hydroxide, which is gonna be like a magnesium is 2 plus, hydroxide is OH minus 1, so it would be like this comes here and this comes here, so like the 2 goes with the hydroxide, and here's a 1 that is like invisible.
Okay.
And it is always in AQ state specifically.
AQ. Yeah.
Then it goes like one arrow specifically because the reaction is irreversible.
Yeah, the reversible. Then the arrow with H2O.
Exactly, because it is dissolved in water, and it's gonna dissociate like a magnesium 2 plus in aqueous, and the other part is the hydroxide ions, like this. And if we balance this, we'll have like 1 and 2. You following me?
Yeah, okay. Yeah, okay, so I see. So you use the okay, so the thing you do is that you reverse it a bit, and when you roll it to the other side with the H2O.
Exactly. Basically, well, the numbers, well, here it's always a 1, and here it depends on these numbers specifically. Okay, so part B, conversion factors. Basically, we have to convert, always we could convert the grams to moles, and then the liter, in this case megaliters, to liters. So this is 4.80 times 10 to the 9 picograms of magnesium hydroxide specifically. Okay, so we have picograms. So pico means, so 1 picogram is 10 to the minus 12 grams, or we can also put it like 10 to the 12 picograms is 1 gram. Like, either way is fine. Either you put the negative exponent on the top or positive below.
Oh, okay, that's why you put that a few times in one of the problems.
Exactly.
Because of the negative. Because it will still be the same.
Exactly. Because when we have the negative exponent, as we saw in math many times, we just basically bring it down to make it positive. So now that we have it in grams specifically, we convert it to moles with the molar mass. So the molar mass of magnesium hydroxide, well, we have to look at the periodic table. Okay, magnesium has a molar mass of 24.305 plus, plus, and be careful here because we have a 2. What I recommend you is put the 2 outside and you put like a parenthesis and you calculate this inside. Like oxygen is 15.999 plus hydrogen is 1.008. You following me?
Yeah. Oh, okay. I see. Because of the 2 outside the OH, we have the value of magnesium, but after we have that added with 2, and inside that's where it is the OH added. That's why we get 58.319.
So this is gonna be the molar mass. Like there's 58.319 grams of magnesium hydroxide in 1 mole of magnesium hydroxide. And with that we have the conversions. We just have to plug this into the calculator specifically. And this is gonna give like 8.231 times 10 to the negative 5, if I'm not mistaken. And the unit for this is moles of magnesium hydroxide.
Yep, that is correct. Okay.
Yeah, so now we have the mass of the compound in moles, and now we're gonna convert this to liters. So 3.50 times 10 to the negative 5 megaliters. Okay, so 1 megaliter means 10 to the 6 liters. So if we multiply that out, it's gonna be like 35 liters, if I'm not mistaken. Yeah, right, 35. You calculated too?
Yeah, I'm taking that also with my calculator. Yeah, it is.
Okay. So what we're gonna do with these two values now is calculate the molarity to determine the concentration of OH ions. So this is part C. Remember molarity, like the concentration of
molarity
OH is gonna be like the moles over the liters. Well, specifically, this is not gonna be OH yet. It's gonna be the concentration of magnesium hydroxide. It's gonna be this divided by 35 liters. Which is gonna give like 2.35 2 times 10 to the negative 6. And the unit for this concentration is molal, like uppercase M. or capital M.
Yeah, capital M.
Okay, so
That's a much better way to
this
say
is
it.
this is the concentration of magnesium hydroxide, but we want specifically the concentration of the hydroxide ions. So look at this. Here we have a 2. This means that for every mole of magnesium hydroxide, we're gonna have 2 moles of hydroxide ions. So basically the concentration of hydroxide ions is gonna be 2 times the original concentration, which is this one. In a nutshell, we multiplied this times the number of the OH that is here. You got that?
Yeah.
And this is gonna give like 4.704.
4.704 times 10 to the minus 8.
Exactly. Okay, we have now the concentration of hydroxide ions.
Yeah.
Okay, calculate the pOH. So let's look at the formulas. Okay, how can we calculate the pOH if we have concentration of OH? Well, here it is. It's basically minus log of the concentration of hydroxide ions. So pOH
Yeah.
is minus log of this specifically. So it is gonna give 5.33.
Yeah, 5.33.
Exactly.
Hmm.
Okay, that's the pOH. The last
Yep.
thing
The pH.
this asks for is the pH. Now, by the way, this
Yeah.
is part D, and now part E, the pH. So basically, we subtract 14 minus the pOH because of basically this formula. If we isolate for pH, it's 14 minus the pOH.
Yeah, I see. Okay.
And this is gonna give me like 8.67.
8.57 pH.
And we can see that this answer makes sense because our original reaction was like this is a base because it has hydroxide ions, and
Okay.
whenever the pH is like greater than 7, it's gonna be a basic solution, so it makes sense that pH has this value.
Yeah.
So what we did is correct.
Exactly. Wait.
Okay, questions up to here?
No, good. I'm understanding well. And learning well with these formula. That's the problem.
Okay, next problem. So a solution contains 2.10 times 10 to the 6 nanograms of iron 3 hydroxide in 5.0 times 10 to the negative 12 teraliters of solution. Write and balance the chemical equation, conversion factor, blah 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 blah. Okay, so write the chemical equation.
The balance of the chemical equation.
Okay, so yeah, we're gonna leave the space for the numbers, and we're gonna write down this formula. So iron 3. This means this iron with a positive 3 charge specifically, and hydroxide. so OH minus. So this means it's gonna be like the 3 constant here, and here remains an invisible one. So basically like this. And this is always in aqueous state specifically. So this dissolves in water, and it's gonna dissociate into iron,
Yeah.
3 ions,
3 iron, yeah.
aqueous, plus
What?
H,
OA.
like OH minus aqueous.
Yeah, OH minus, and that's AQ.
So to balance this, okay, this is always 1.
Yeah, that is always
one,
1.
and
1,
this gonna
and the
be
other one 3. We skipped
Exactly.
the 2.
Okay, so we have part A, now B, conversion factors. So basically the same thing over again. We're gonna convert this into moles. Okay, so first, okay, this is nanograms of this specifically. I sometimes forget to write the compound in the grams.
Yeah, and it's important to write those so that way the teacher will know which one is the one that we're graphing for the molarity.
Exactly, because it's not about any compound, it's about this compound specifically.
Mm-hmm.
Okay, so nanograms. Okay, basically 1 gram is equal to 10 to the 9 nanograms, or the other way around. We can put 10 to the minus 9 grams above and 1 nanogram
And
below.
1 gram
Either way.
under. And it still works, okay.
Exactly. Either combination works.
Yeah, either way works, you man.
Exactly. So now we're gonna have to calculate the molar mass. Okay, so the molar mass of iron is specifically 55.845 plus, and we have the 3, and inside 15.999 plus 1.008. So this molar mass is gonna be 106.866. So grams of iron 3 hydroxide is equal to 1 mole of the same thing. So we basically plug all these into the calculator, and it gives us the answer 1.965 times 10 to the negative 5 moles of iron 3 hydroxide. Okay, we did this conversion factor, and now we're gonna convert the volume of the solution. So 5.0 times 10 to the negative 12 teraliters. So 1 teraliter is equal to 10 to the 12 liters. So basically, well, this and this kind of cancels, and it's gonna give like the same thing but in liters. So we did the conversion factors part, and we're gonna now calculate the molarity. So first, the concentration of iron 3 hydroxide is gonna be this divided by the liters. So this over 5 liters. So this is 3.93 times 10 to the negative 6, capital M. So now, to find the concentration of OH ions, we just multiply the 3 times the original concentration. So this is gonna be 1.179 times 10 to the negative 5 molal. And now
Exactly.
we're gonna calculate
The pH.
the pH. Well, this problem is like a bit weird because okay, it's asking us for concentration of H plus, but this is a this hydroxide. This is a base, so okay. Well, I think teacher meant the most likely meant OH here, but okay. Anyways, it's still possible to calculate the concentration of hydrogen because there's a formula that relates these two, which is this one. Basically, concentration of hydroxide ions times the concentration of hydrogen ions equals 1 times 10 to the negative 14. So we basically pass 1 to the other side dividing, and that's it. So the concentration of hydrogen ions is gonna be this, which is this. Well, no, the other way. No, this goes above, and the other one goes below. Yeah, specifically, like it's not about.
Yep.
It's not about the other way. It's about this way specifically. So this is 8.482 times 10 to the negative 10. Yeah.
Yeah.
Specifically, molal. I almost forgot. Okay, so now, we have both concentrations, so we can calculate both POH and pH. So, calculate the pH. Okay, it's gonna be minus log of the concentration of hydroxide ions. I mean hydrogen ions, specifically.
Yeah.
It's kind of confusing. Like hydroxide, hydrogen, they're like so similar. Okay, 9.07. And now
Yeah.
the pOH, we can use either this or this.
Or
Okay, but I
let's use
prefer
pH plus pOH equal 14.
okay, 14 minus this thing.
Yeah, 14 minus 9.07.
4.93.
Yeah, 4.93.
Okay. And by the way, the pH is greater than 7, which is correct because it is a basic solution.
Yeah,
So it's correct.
true. Okay. Next question.
Okay, so a solution contains 7.60 times 10 to the 10 picograms of calcium hydroxide in the medium of solution. Okay, right. And balance the chemical equation. Okay, we know the drill. Okay, calcium hydroxide. So calcium has a charge of positive 2 and hydroxide is negative 1, so the 2 comes in here and that's it. I'm gonna go like fast now.
Yeah, we might want to go fast. It's already
Okay,
been like
so
27 minutes since we started.
exactly. Okay, so the arrow with the water, specifically one arrow, not like this specifically.
Yep.
And this is gonna dissociate into calcium ions in aqueous state plus hydroxide ions also in aqueous state.
Yeah.
And
we know what that means.
one,
1, 2.
Exactly. Okay, conversion factors. We have 7.6
Okay.
times 10 to the 10 picograms of this. Okay, so picograms, like, oh, someone's coming. Kevin.
Wow.
Specific.
Hi.
I'm right here.
See,
There's
we
nobody
kinda,
else.
Nobody else.
This
Yeah,
sucks,
just
man.
me and him, but now it's the three of us.
Tomorrow the people are gonna be like,
Yeah,
Yeah,
like
today with the match you're like but tomorrow you're gonna be like, hey, I don't understand chemistry, I'm not ready.
yeah,
This
like
class is gonna fuck me. And
okay, buddy.
yeah, okay.
Anything.
Let's continue.
Well, I will let you guys finish this and then pay attention because you're already so in.
Yeah,
No,
okay.
dale, estamos empezando. Mira, básicamente, o sea, estamos empezando el tercer problema.
Yeah, okay.
O sea, básicamente, so basically you have like a calcium hydroxide, which is this. So calcium has like 2 plus, and you bring this here and then this is aqueous always, like the 99.99999% of the time. And then you put like one arrow specifically, like not 2, no, just 1, because this is an
Why is that
irreversible
too? Hold up.
reaction.
What does it?
This is an
Ah.
irreversible reaction. Like this dissociates like 100%. Like it goes from here, but you can go back.
Okay.
There's no way back.
But does the problem says that or not? The problem doesn't say that. Like it does not associate.
Que la teacher dijo que esto solo was specifically the strong acids. ¿Y qué pasa con los strong acids? Que se disocian completamente, al 100%. Like 99.999.
Calcium hydroxide. Okay.
But like in the test, you're gonna have to memorize which acids are strong and which bases are strong, and if it's not strong, then it's weak. We're gonna see it in the next
No.
class.
I obviously know if it's not strong, it's gonna be weak. I guess there's no other.
Yeah, I guess.
Okay, wait. But also, we just have to memorize them. Oh, I hate this.
¿Qué cosa?
O sea, lo tenemos que memorizar todos.
Ah, sí, exacto. Literalmente.
Yes, you have to memorize the
Lo que siempre
formula.
dice
and
Killimek.
also- Mhm.
Dije, entonces hay que memorizárselo. Sí, en este caso se hizo canon, hay que memorizárselo. Ok, so basically, bueno, ahora estamos convirtiendo esto, like 10 to the 12 picograms is equal to 1 gram. And then we do like the molar mass of this, which is like 40.078 plus 2, 15,999 plus 1.008. Which is like 74092. Grams of calcium hydroxide, and this is equal to 1 mole of calcium hydroxide. O sea, básicamente siempre, like the 99.9999% of the time, you always convert the mass into moles. Why? Because it's gonna be later. It's gonna be useful later. I mean, to calculate the molarity. Do you understand what I'm saying?
Yeah.
Kevin?
I'm not paying attention, but yes.
Okay, well.
Is he going too fast or too good?
Ofi. I'm going too fast or good?
Good.
Ok. Bueno, básicamente ya tenemos los moles. Y después de eso, we're gonna convert this to liters, specifically. Okay, megaliters of solution. So 1 megaliter is 10 to the 6 liters. So this is gonna be like 820 liters. Wait. Yeah, it's minus 4. Okay, yeah, the 820. Okay, that's like maybe too much, but it's okay. We're not gonna question that, because sometimes the problems are like. You remember like the physics problem, like each capacitor is a planet. The circuit's like
Yes.
Ovi. Yeah, like in here, in the theory, in paper, the circuits are like but in real life, it's not gonna work. Dios mío. This brain rot is gonna get more and more. Okay, now we're calculating the concentration of, in this case, calcium hydroxide. Básicamente dividir los moles que obtuvimos entre los litros, specifically. Okay, 1.251 times 10 to the negative 6. And the unit of this, okay, Kevin, what is the unit of the concentration of molarity? A ver si de repente te acuerdas.
M.
Exactly, specifically, una M mayúscula. Muy bien, Kevin. Okay, entonces ahora, de aquí, como esto es una base, podemos sacar la concentración de OH, o sea, de los hydroxide ions. Básicamente es multiplicar este 2 por la concentración original. Do you understand what I'm saying?
Mm-hmm.
Yeah.
Of it. So like 2.502 times 10 to the negative 6 m. Okay. Okay, calculate exactly. Calculate the POH. Okay, so the POH, if we have the concentration, then it's gonna be like negative log of the concentration. This is like a formula. All the formulas are in here, by the way. Oh, ya las envié al grupo general. Y si en vez del grupo general fuera grupo específico.
I don't know.
No, tenías que
No
decir. Gracias.
Gracias, compas.
Israeli. Muchas gracias. And lastly, calculate the pH, which is gonna be 14 minus the POH. And this is gonna be 8.40. Remember, always 2 decimals after the
After the decimal point.
Exactly. Even if here's a 0, we have to put it like always. We're gonna have 2 decimals. That's what the teacher said. So yeah. Okay, these problems are getting like too repetitive, like exactly the same process.
Yeah, they're like too repetitive and
yeah, let me look for if there's like a different type of problem
that we can do.
Okay, number 7 is different. Let's do it.
Okay, here we go.
Okay, a river water sample is analyzed and found to have a pOH of 4.15. So part A is calculate the hydroxide ion concentration. Oh, so now it's backwards. They give us the pOH and we have to find the concentration starting from there. So for these cases we have these formulas. So in this case, with the pOH we can calculate hydroxide ion concentration with this, like 10 to the negative pOH. So it's gonna be the concentration of hydroxide ions gonna be 10 to the negative 4.15. Which is 7.079 times 10 to the negative 5. Remember, the unit for concentration is molal. Okay, calculate the pH. This one is easy because we already have the pOH. It's just 14 minus that. 9.85. Determine the hydrogen ion concentration.
You meant
Okay.
9.85.
Yeah, exactly. Sorry. 9.85 specifically. And now determine the hydrogen ion concentration. So similar to the hydroxide ion concentration, we're gonna calculate the hydrogen ion concentration as 10 to the negative pH, which is 9.85. So 1.413 times 10 to the negative 10 molar. Yeah, that's basically the problem. Okay, let's do number 8.
Correct.
Questions up to here? Kevin, you good?
No questions. I'm good. Kevin?
Yeah, continue.
Ok, bueno, tampoco le puedo decir mucho a Kevin porque al final él sabe que vamos juntos así, relajado.
Yeah, exactly. It's better that we don't ask him. He's
Okay,
just
igual, o sea,
watching.
como tú dijiste, o sea, I'm trying to pay attention, but I'm doing my stuff, so.
Es que, like, killing the virus.
Yes.
Okay, calculate the hydroxide ion concentration. And we have already the pOH, so the concentration is 10 to the negative pOH, which is 9.47. So 3.388 times 10 to the negative 10 molar. Okay, calculate the pH. If we already have the pOH, then it's just 14 minus the pOH. .53. Determine the hydrogen ion concentration. Well, the hydrogen ion concentration is 10 to the negative pH. So 2.951 times 10 to the negative 5 molar. And that's it. Another type of repetitive problem. Let's see if there's like a different problem. Okay, let's do 15 and I think we're good. It seems like we've done like poco, but I'm telling you that the problems are like mostly the same. So if you know like 2 or 3 types of process, then you're basically ready for the classwork.
Yeah, I'm feeling prepared, Diego. Let's do this.
Okay, so write and balance the chemical equations. Okay, and this is an environmental chemical plant determines. Okay, perchloric acid. Perchloric acid. So this is an acid, so it has H. And perchloric means perchlorate, which is ClO4. This has a charge of -1, and hydrogen is +1, so it already is balanced. This is always in aqueous state, and it's gonna dissociate in water as H plus aqueous plus perchlorate ions in aqueous state as well. Like everything always 99.99% of the time in aqueous state. And this is just 111. Okay. B, calculate the concentration of hydroxide ions. So here we have that's nice. They already give us the moles. Okay, that's nice. We don't have to do conversion factors. Just divide this with the liters, which are already in liter. Like it's not megaliter, milliliter, anything like that. Just liter. Nice. So this is 4.583 times 10 to the negative 14 molar. Okay, so this is the concentration of the acid specifically. Like this. But since everything is 111, then this is also gonna be the concentration of the hydrogen ions. Hydrogen ions, why not? So why this specifically and not OH? Because this is an acid, and acids have these like hydrogen ions. Do you understand what I'm saying?
Yeah.
Okay, but they ask us for the concentration of hydroxide ions. So we have the concentration of hydrogen ions. We can use like this formula to get the concentration of the other ions, in this case hydroxide ions. So the concentration of hydroxide ions is gonna be 1 times 10 to the negative 14 divided by the hydrogen concentration, 4.583 times 10 to the negative 4. And this gives us 2.182 times 10 to the negative 11 molar. And that's it. Basically that's it. Questions up to here?
Can you repeat
Nope.
everything again?
It's not gonna work.
Yep, it's not gonna work. Just
Okay, well, if we're done, I'm gonna send...
Wait, is the test gonna be this easy? Because I see it as kind of easy.
No, it's not. This is not the test. This is the classwork specifically. The test.
yeah, it's a classwork.
Yeah,
Remember,
okay.
it's a pairs of two. Remember, you
Yeah.
go here.
The test
Each
is gonna
one of
have
it.
like theory. It's gonna have weak acid, weak bases.
Yeah,
you're gonna have to
etc.,
use like
etc.
ice tables with quadratic formula. And
100% sure I'm not getting attempted, but okay.
de verdad, Kevin, ¿por qué al pesimismo? Tú puedes.
Yeah. Yeah, like, it's not getting a bit simple till it gets a lot more complex. That's the whole point.
Wait, let me see my grades right now.
Okay,
It's not bad.
Voy a parar de streamear ya.
Yeah, sure.